What American companies should know about the Department of Energy's laboratories is that in many cases we can jumpstart the work that you're already doing. For instance, from my time in private industry, there were many things that we did where it took enormous amounts of capital and enormous amounts of facility space to do very basic things. Here at the department, those facilities already exist, and we invite you to join us.
Early stage research is essential to create more reliable and low-cost energy storage options for transportation and the grid. NREL and the other national labs and the research community are looking forward to taking on those challenges.
Berkeley Lab is using NERCS, which is one of the supercomputing centers funded by Department of Energy, to discover new battery materials on the computer so that we don't have to do very expensive experiments to figure out the next generation of battery materials.
A synchrotron produces very high energy X-rays. The high energy X-rays allow us to study batteries while they're working, to understand where the electrons are going, how the materials are changing real time as the batteries function.
Energy storage technologies are a key element of our future energy infrastructure. We envision a future with orders of magnitude increases in the amount of energy storage that we apply to our energy systems on the electric grid, in the transportation sector, and in a bunch of other areas.
ORNL has a very diverse portfolio of battery research projects that span from basic materials and chemistry research to applied manufacturing and looking at prototypes of batteries.
Argonne right now is thinking hard about how to decrease the cost of batteries while simultaneously improving the life of batteries. We're also thinking about how to fast charge batteries. We have an ambitious goal of charging batteries in 15 minutes. We think this can be a game changer.
Working with industry, our partners from other national labs, and working with DOE, PNO would like to develop the technologies beyond lithium-ion batteries that can be 2 to 3 times cheaper, but can store large amount of energy over a long duration of time.
In an industrial setting, often we're concerned with delivering the next best battery or energy storage technology. The underlying challenges are, how do we deal with optimization? How do we deal with scale up? At SLAG, we are well positioned to understand all of these different mechanisms, whether it is making the battery charge and discharge faster, putting more energy into a battery, or making it longer lasting and safer.
In mobility, in personal electronics, and in large-scale energy storage. The application of batteries can be done to a vast array of potential areas, and we want to hear from you about the potential applications so that we can figure out where to go, increase our focus of research that might have a real impact to the broader economy, to broader enterprise, to the American people.